we've seen that the slope at the 0.8, 0.4 point of the solution curve for any differential equation x prime equals 3x minus 2t is going to be negative 0.4. Now let's see what that tells us about the behavior of the solution curve. Well, if we have the point 0.8, 0.4 and a little segment indicating the slope, which is negative 0.4, what does this mean? Well, this means that if we move from this point any distance to the right, we can form a right triangle with a rise. Now if we're moving from this point to the right, the rise will be downward, and a run. And that the rise divided by the run is going to be about negative 0.4. Now at this point, the closer we are to the point, the less distance we move from the point, the closer our rise over run, the closer our slope will stay to negative 0.4. But we know that because of this relationship, that when x and t start changing, our x prime is also going to change, so that the rise over run won't remain negative 0.4. However, if we run just a little bit and rise just a little bit, the slope is not going to vary too awfully significantly. So let's assume a relatively small run of delta t equals 0.1. Now our rise is our change in the x-coordinate, because our x-coordinate's being represented by the vertical axis, and our run is the change in our t-coordinate. So we're assuming the run delta t is 0.1. What do we conclude? Well, if rise over run is negative 0.4, then our rise is going to be about negative 0.4 times our run, which is negative 0.4 times 0.1, which is 0.04. What does that do? Well, if we start at 0.8, 0.4 and move 1 unit in the t 0.1 unit in the t direction, we're going to get to a new point which has t-coordinate 0.9, having moved 0.1 unit from 0.8, and let's see, that's negative 0.04, and 0.4 minus 0.04, which is 0.9, 0.36. So that our new point will have approximate coordinates 0.9, 0.36. We'll see what the implications of that are in the next clip.